All right. So let's. It is, yeah. So it starts back up in the fall. It's only fall semester. Huh? All right. So let's talk about this semester. Okay. So in my experience, as far as teaching goes, this semester is faster than the fall.
Really?
So we have a couple of Mondays that we have off due to different holidays in both January and February. And then March is kind of a long month. In April, we have our spring break. And then, but there's a couple days that there's state testing. There's some days that are where we have certain levels of kids that are here, maybe juniors or sophomores, but not everyone else. So it's just kind of, the nature of the spring semester. We go from cold to a warmer, which is a different type of thing rather than going from warm to cold, even though our winter didn't really show up until last week, it seems like. So that's just a few things. So let's talk about grades. And I'm just talking about overall grades in any class, not just this class, but any class. So what are some things, if you were happy about the grade that you earned, I would say don't change a thing. Keep doing what you're doing. Okay? If you're kind of like, shoot, I wish I would have gotten better, well, don't do the same thing and expect different results. By definition, they classify that as insanity. Keep doing the same thing over and over and over again, going, it's going to be different this time. No. It's going to be different this time. No. So, if you didn't like where your grades were, change what you're doing. Now, my office hours for you all is a little different this semester, which is fine. I'm here before school. I'm also off first period. I'm off third period. And I'm off fourth period. So before school, first, third, or fourth. If you can get here before school, cool. Those of you who say, oh, well, I'm only available after school. If that's the case, then you can be here before school as well, because that means you're waiting for a ride or some sort of ride available for you. That's for me. If you want extra help, if you want to be the person saying, you know what? Maybe I should come in and see Mr. Stroud. Maybe I should come in and do my homework for math during one of those times. Maybe that would be the difference between your grade that you earned last semester and earning a better grade this semester. Okay, so think about what might work for you. And my office is pretty easy to find. It's 439A. It's in the West Building. It's just down the hall, right over there. My name's on the door. Find it. Okay? So if that's you, if you're happy with how your grades were, I'd say don't change what you've been doing. If your grade stinks, and I'll tell you, some of you barely passed. Meaning you had like a 60.0%. That's not a good grade. Okay? Some of you waited until like 7 seconds before the end of the semester to say, oh, I actually care now about my grade, so what can I do to pass? Probably nothing. Don't wait till the end. Don't wait till the end. If you wait to the end, I'll tell you, if you thought December 2.5 weeks ago was too late, you wait till May, right before graduation. It's going to be quick. So, if you're pleased how you did, please continue doing it. If you want to make a change, it starts now. Okay? If you're content with D's, shame on you. I'd say this. Make a goal for yourself. Make the goal to try and earn a higher percent grade than what you had last semester. I don't know what that was. Well, go look it up. Okay? So that's just some things. Other things that are available that we are looking for. We are finishing up our workbook from last semester. Okay? Being that we were about a week or two short, we still are using last semester's book for this week and into next week. Okay? If you tossed it, you got to let me know. I made some copies for today, and then I'll cover you throughout the rest of the week, which I'm happy to hand out. But these are notes. So there are some of you that I would hand out notes to, and as I'd walk around the room, you'd have nothing on it. You would write nothing down. You'd be like, oh, I don't learn that way. Maybe let's try something different. Like, when I do examples on these sheets, I'd say, try it and copy it down. Sitting there with your arms crossed with nothing out is not a good thing. When it comes to the end of the period and I'm kind of cleaning up the room and y'all have left and I've picked up 4 or 5 of these because you decided, oh, I don't need that because it's overrated, you might be wrong. One short. Don't hold that against me. I just yeah, you know. So let's catch ourselves up. So before we left, we had learned about, we had graphed, and this is not on the notes, so you don't have to take this. We had learned, hey, I could graph 2 different lines, and where they cross is called our solution. Remember that? You can do it, Joe. I can talk over you. So, where graphing fell short is where you came across decimal or large answers. Or if you were trying to straight-hand it, or freehand it, where you didn't have anything, that made it tough. And we know that when you find the solution, if the solution is x comma y, if you plug these back in, if you get true on both statements, that means that's good. That means that truly is a solution. There are times that when you freehand it and it looks like it crosses at, in this case, -3, 0, you plug that back in and it works on one but not on the other, -3, 0 isn't the solution for both, so you might have made a small error. Okay? And then we moved on to where we did substitution. And that was where you got one problem saying y equals or x equals, and you plug that into the other problem and you started solving it. Right? So let's take a look at the warm-up. The warm-up appears to be, our first one is y is equal to 2x plus 2, and x is equal to -y plus 5. This problem is set up to do substitution. It's very clear that it's set up to do substitution. Why do I say that? Yeah.
Because the y and the x equals something, so
Yeah.
we can plug them in.
So we know that y on our first equation is equal to the relationship 2x plus 2. So that means I can take that 2x plus 2 and plug it into the y on the second equation and solve it. Or I could say, I know that because of our second equation, that x is equal to -y plus 5. So I could take -y plus 5, plug it into the x in the first equation, and solve that. Which way is the best way to do it? They're both going to get you an equivalent answer. So I think, let's take this, because y is equal to that, and I have a y right here, agreed? So I can take that 2x plus 2 and plug it in. what's going to happen when I plug it in? So x stays as is. I have a negative here, plus 5. This was a negative y. What's going to plug into where those parentheses are? 2x plus 2. Why did I put it in parentheses? I'm plugging it in for the y. I'm not plugging it in for the negative y. I'm plugging it in for the y. Does that make sense how I just said that? So what should I do with the negative? Distribute it over the parentheses alone. Okay, so this is, again, this should look somewhat familiar. So I get that. Does everyone agree? Negative times 2x is negative 2x. Negative times 2 is negative 2. And then I have the plus 5 that comes along for the right. Combine any like terms that I might have. So x is equal to negative 2x. Negative 2 plus 5 is plus 3. How should I get x by itself? Yeah.
Plus 2x.
Add 2x to both sides. Now, guys and girls, if I go over something too quick and you're like, wait a minute, I'm still on winter time, stop me. Ask me. I have 3 times x is equal to 3, so I'm going to divide each side by 3. And this is going to allow us to see that x is equal to 1. Yeah.
Could you also do that when you plug x into the...
Uh-huh. Be the same thing. Hey, so I have part of my answer. I have x comma. What do I need to find? I need to find y. Okay? So I can take my new x value and I can plug it into wherever I have. So I have an x value that I found was 1. So I can plug it in here or I can plug it in here. Which one appears to be the better one? What letter am I trying to solve for right now?
Y.
Y. Is one of the equations set up as y equals? It is. Which one? Top or bottom?
Top.
Top. So I could plug the 1 in here and get y by itself. Or I could plug it in here and it's going to give me exactly the same answer. So that is what my y value is equal to. So if I had graphed this, it would have intersected at 1, 4. So this was substitution. Meaning I take one equation, solve it for a letter, plug it into the other one. Is there any questions on that first question? Or first problem? Second one, just to the right of it. So first question I wanted to just ask real quick. Have I solved for a letter on either of the problems? No, I probably could, but are either of the problems y equals or x equals as is?
No.
Okay? Now, let's do something. Let's change the wiring of you guys real quick. When this type of first problem is first introduced to you, let's go back to first part of November. Or let's say you're sitting at the ACT for the very first time, and you have this problem given, so solve it. What is the very first intuition that comes to you when you have these first two problems? Like, let's say you have no idea how to do the substitution, no idea how to do the graphing. What would the very first intuition be to do on this problem?
I have all the parts for slope-intercept form.
Okay, slope-intercept form maybe. What else? I heard a mumble. Somebody said something? Do what? Solve for the variable. Okay. But let's go back. Let's go back to September. If I were to put this problem up on the board, what's the very first thing you think to go for?
So get rid of one of the variables.
Get rid of one of the variables. Okay, so I would do that maybe by subtracting or adding. So, like a very first thing, like if you have something that's given to you in the very beginning of the school year, some people might say, well, what happens if I add these together? Well, look what happens here. How did that happen? I had 2x and negative 5x, and I got negative 3x. Okay? But what happens if I add the y's together? Where do they go?
Cancels out.
They cancel each other out. Why do they cancel each other out? Thank you. Oh, she's no longer in this class. They cancel each other out because they are opposites of each other. I have a positive y and I have a negative y. They're opposites of each other. And then I get this. Now, if we had given you that kind of problem set up originally and you went and added them together and you're like, oh, look. So what does x equal to if we solved it this way?
-2.
-2. If I divide each side by -3, 6 divided by -3 is -2. Okay, I know I have to get an ordered pair. What should I do with that -2, which is an x value? Plug it in. Okay, so I'm going to take my x value, and I'll plug it into either of the two. Which one's best? I don't know. You pick. I would probably pick the top one. I have 2 times plus y equals 2. I'm going to plug -2 in here. Add 4. So look at that problem. I did not use substitution. I did a basic instinct of math and said, let's just add these two together. I got real lucky that by adding the two equations together, that one of the letters canceled out with one of the letters in the other equation. Agree? So this is actually the more formidable way of thinking through problems. Okay, this is something that if you don't know how to do a problem on a test, this is actually the thought process that probably comes to mind to do first. What if I just add them together? Why do we go there? Because addition is the very first part of math you really learn about. It's the way of counting. And it's the way that you feel the most comfortable with. Okay? When you were learning how to do math in elementary school, you learned how to do addition first. And then you had learned how to add the opposite, which was then called subtraction. Then you learned multiplication. Then you learned division. And everyone hated division. And then we introduced something called fractions. And you want to know why you hated fractions? Because fractions and division are the exact same thing. So if you hated division, no wonder you hate fractions. Make sense? And now it's all starting to come together going, wait a minute, that's what happened in 3rd grade. I thought it was because they cut recess by 5 minutes. No. We tried to sneak in a different version of division to you and called it a fraction. Okay? So the very first mathematical thing you learned was addition. Yeah?
So on these problems, can we I guess manipulate the problem to make it x and y equals? Would that work?
Mm-hmm. You could. But we're going to steer away from it. Okay, so notice that second problem, if we had manipulated it to get x or y by itself, we could have worked it, but I just worked it just below. So if you copy down on number 2, I just worked it out. This is called the elimination method. So let's go down to the example 1. It's on the bottom of the first page. We have 5x minus 6y is equal to -32. And you had 3x plus 6y is equal to positive 48. Okay? Let's go back to our basic instinct of math, addition. If we add these two things together right now, does one of the letters eliminate the other letter?
Yes.
Yeah. The y's are opposite values of each other. Do you agree? So this is kind of nice where it's like, well, I liked adding. Adding I found was easy. It was just like counting. Okay, so 5x added to 3x is 8x. What happens here and here? They're gone. This was nice. They were lined up with each other. This was pretty nice. And if I add -32 to 48, I wind up with 12, and I'll let that sink in for a second. No, I take that back at 16. Boy, I tell you, I think that's gone for 2 weeks in a day. Okay, does that make sense? 48 minus 32 is 16. What's x have to equal then? 2. 8 times what number gives me 16? So if I divide each side by 8, I find that x is equal to 2. That's the first part of my answer. That's an x and y value. What should I do with that new x value I just found? Plug it into one of them, okay? So I have an x value here, agreed? I could plug it in here or here. Steve, after you get your SIP, which one should I pick, the top or the bottom equation? Your choice. Top, okay. So Steve chose to pick the top. Now some of you are going, God, why didn't he pick the bottom? Because his mind worked to pick the top. It's going to be the same answer regardless. I like it. So I'm going to plug 5 in, or plug 2 in for the x. Agreed? That's 10 minus 6y equals negative 32. Subtract 10. Those cancel. Negative 6y is equal to negative 32 added to 10.
Minus 10. Negative 42.
Negative 42. So negative 32 minus or plus negative 10 or minus negative 42. Yeah, my tongue will. All right. How do I undo this? Divide each side by negative 6. So y is equal to negative over negative is positive.
7.
42 divided by 6 is 7. So my answer to this problem is 2, 7. What do you think? If I plug that 2, 7 back in to both of the equations, I'm going to get a true thing happening. The top one would give me negative 32 is equal to negative 32. The bottom would give me 48 equals 48, which is supposed to happen. Okay? So, I want you to try this one real quick. This is on the back of the first page. I have 2x minus 5y is equal to 17. And I have 6x plus 5y is equal to negative 9. So would you try that one real quick? I'll give you about a minute head start. And then I'll kind of start jotting down. See how you do. Check up there, see if you match up with what I did. Keep going if you do. Make the modification if you need to. Get that? If not, did I do it right? Because it's possible I goofed up.
Like the shifts down too.
And just a quick reminder, you all remember that I do record all my lectures and that's put on YouTube. So go to YouTube, search for Mr. Stirrups Classroom on YouTube and you should be able to find it if you don't remember. If you still can't find it, email me and I'll send you the link. Just in case you need to go back and watch it. It's just the raw footage of the lecture, so I don't pause it between questions. What do you think?
Yep.
We've been guiding you all along on this, right? Is there any questions here? Good. So let's take a look at this next one. I have it as number 3. I have 7x plus 2y equals 10. negative 7x plus y is equal to negative 16. What's different about this problem? What's going to fall out? The x's are going to fall out on this one. Okay. So this still works nicely, and I'll just kind of peruse through it. So those cancel out. That gives me 3y, because 2y plus 1y is 3y equals negative 6. Which value did I solve first? Y. Remember, back here, I solved x first. Back here, I had x first. Back here, I had x first. But now, we have y happening first. So we have to make sure, if I do this now, what do I plug back in? What number do I plug back in? Negative 2. And negative 2 gets plugged into what letter? The y. Okay? So I have this y value here, which is this. So I need to plug it in either here or here. We have to pick one of them. Doesn't matter which one. I'll pick the top one here. So I have 7x plus 2 equals 10. This was a y. What's going in there? Negative 2, yeah. I guess I could rewrite it like this. What should I do with this minus 4? Add it to both sides. Okay. 7x is equal to 14. X is equal to 2. So you can also get the y value you could solve for originally first, and you plug that back in. Just remember, if you solve the y value first, the y value has to go in for the other y variable. It doesn't go in. If you solve for y, don't plug it in for x. Or if you plug for x, don't plug it in for y. Plug it into the right location. Ready? Poke your neighbor in the eye real quick. Just not like taking out the eye, really. Rom, you might get hurt poking that one.
Yeah, I might.
All right, so put your pencils down and just look at this one real quick. If I go and add these together right now, I get 8x, agreed? Plus 12y equals 52. Did I solve for a letter? No. So that might be a go-to. This isn't going to work. The way we've seen these, we're all falling out. I like that. It might not have a solution. I will tell you, this probably does have a solution. I would say that we could probably try and graph it, or we could probably use substitution. The second one, I could go, x equals 3y plus 20 by adding 3y to both sides. But I haven't been setting it up that way. I've been setting it up where they're all kind of lined up in columns. The x's are lined up right above each other. The y's are lined up right above each other. So, this is a little different. This won't add to where a letter goes away. Does that verbiage make sense? Does everyone agree? If I add these two equations, I mean, up until this point, I was able to add things together, the two equations together, and they fall out. Because I had opposite types. I had opposite values on my letters. But this one doesn't happen. Okay? So, let's take a step back and think about this for a minute. Let's take the fraction 1 over 2, 1/2. The fraction 2 over 4 is the same fraction. The fraction 4 over 8 is the same fraction. 8 over 16, 30 over 60, 100 over 200, 1,000 over 2,000. It's all the same thing, but what are those fractions not done? They're not simplified. We didn't reduce them, right? So what we're going to do is we're going to kind of goof the system up a little bit. And unfortunately, in elementary school, you were indoctrinated to know that you have to have every fraction as a reduced form. Okay? We already dealt with that last semester a lot because there's times that I put an improper fraction, meaning I had the top number bigger than the bottom number. And a lot of you are like, oh my gosh, we got to go to a mixed number. unfortunately, mixed numbers aren't always the best way to go. Mixed numbers are the things that aren't accepted. The mixed numbers work because that allows you to understand, oh, this is how we're supposed to have this or that. So what I'm going to do is we're going to kind of do something that kind of tickles your brain a little bit. Okay? So I have to now pick. Now this is how we're going to go through it. Do I have, between the top and the bottom, opposite signs?
Yes.
Okay? Are the x's opposite signs? No, they're both positive, right? What about the y's? I have a positive on top and a negative on bottom. Do you agree?
Yes.
So that's the first thing you should look for. Do I have opposite signs? If you do, cool. But what would happen if I were to take this equation here? I'm going to put the whole thing in parentheses and multiply the whole thing by 5. So I'll distribute the 5 here, here, and here. So 5 times x is 5x minus 5 times 3, 15y. And then 5 times 20 is 100. Now I'm going to take my original top one. I didn't modify this one at all. But what do you notice right now? Y's now cancel out. Okay, now wait. So we just went and just undid what seemed natural, and we multiplied to get something bigger. Yeah, go ahead, Ron.
How did you get 5?
Okay, so what I did is I started thinking, going, if I multiply the whole bottom by 5, I know that these are going to be opposite. I already knew I had opposite values here. So I thought, if I multiply by 5 and made this, keep this as 15y, this becomes a negative 15y.
So so the number we multiply by can be anything.
Anything. Absolutely. 5 is not this magical key to undo things. Okay? That's a great question, by the way. I like that. All right, so does everyone agree that this is starting to look similar to if I move back a couple slides? I have opposite y's. I have opposite y's. What do you think? Can the addition thing work here? 5x and 7x is 12x. The y's are gone. 132. Does anyone have a calculator? I can't. So divide each side by 12. X equals 11. Agree? That's an x and that's a y value. Okay. What do you think I should do with that x value? Plug it back in. Okay. So x is equal to 11. So I'm going to pick any of my equations that still have x and y. Wait a minute. Say that one more time. I can pick any of my equations that have both x and y. So it could be the blues. It could be the reds. I want x and y still to be there. Probably makes more sense to pick that one. So I'm going to keep the blue as is. X minus 3y equals 20. Yes, I did multiply to make something fall out. But I'm going to take this whole equation here. Take this whole equation right here. Not the modified version. Okay? So I know that 11 minus 3y is equal to 20. Subtract 11 from both sides. So I get negative 3y is equal to 9. Divide each side by negative 3, so I get negative 3. So my answer to this problem is 11, negative 3. Okay, hang on. I was able to modify one of them, and that allowed me to get opposite y values in this case. It could be opposite x values, though. I solved it, and then I plugged whatever my answer was back into one of my originals or any of the equations that have both x and y. It's a different way of thinking, right? Yeah.
Could you plug in x and y for one of the equations and equals 20 equals 20? Would that help check it?
That would actually be exactly how you check it. Yeah. So if you were to take that 11, negative 3, that x and y value, and plug it into both the equations, the top equation would be 32 equals 32. That's what you want. And the bottom equation would be 20 equals 20. And that means that it's a solution to both the problems. It's the solution means it lays on both lines. If it lies on both lines, it's where they intersect when you if you graph them. Okay? So I know you all have some sort of cell phone. Agreed? Or you have some sort of computer program that requires a password. Maybe? Would that be an okay leap? And yeah, there's always the one kid who's like, nah, don't have any electronics. Like, okay, well, this doesn't mean anything to that kid. But just let's pretend everyone falls into that category. Your password is basically this, and it goes through a system of checks. Now, are some passwords better than others? I don't know about y'all, but I'm starting to become like dumb. Because I just over the holiday I got an iTunes gift card, which is always kind of cool, so I can buy some more music. So I log into my iTunes account. I don't know about y'all, but man, I can't remember passwords to save my life. You go on iTunes like, no, sorry, that's not good enough. They have this little bar down there that's gonna laugh at you if you have some bad password you plug in, or oh, I want to change my password, so I'm going to change it to big boy. Nope, that sucks. It has to be one capital and at least one letter and 14 different symbols. Oh. Shoot. Okay, what should I change my password to? Pound sign. Wait, they don't know what pound sign. That's hashtag. The star. Exclamation point. The little carrot. Wait, how am I going to remember this? I'm just going to hold shift down and then go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then ABC. Boom, there's my password. And it's like, dude, that was a great password. Gave you the green line below it saying, yeah. And if you guys have changed your password on iTunes lately, you'll know what I'm talking about. Boy, I tell you, there's too many passwords out there.
Do they have like a hard disk that they store all that info in?
Supposedly. I guess the government's watching. The government's trying to figure out what's a good password. Let's take a look at this one. But my point on the passwords is our x comma y value is a cheap version of a password that works on both equations. That's all it is. On this one, if I were to add two equations together right now, I'd get 7x plus 5y equals 1. That didn't help much, did it? Nope. Okay, my next step is, do I have an opposite signed x or y values between the two equations?
Nope.
No. Yeah. Oh, I love you, man. Do you hear that? Multiply by -4?
Yeah.
Which one, top or bottom? I can see that. Could I multiply this entire bottom equation by -4? So that shows us that the 5 isn't the key to everything. I'm going to distribute here, distribute here, distribute here. So I get -20x minus 4y equals +28. Wait a minute. If I bring this top one down that has no modifications to it, do I now have opposite y values? All right, let's add these together. I get -18x. The y's are gone. No?
It's negative.
Did I do it right?
X.
-18x. The y's are gone, and 28 added to 8 is 36. Divide each side by -18, so x has to equal what?
-2.
2. So I have an x and a y value here. Agree? I'm going to take my x value. I'll plug it into any of the equations that has both x and y in it. So I can plug it in here or here. I kind of like this second equation here. Even though it was one I modified, I can still use the 5x plus y equals -7. I'm going to plug that -2 in for the x. answer is -2, 3. Oh. That one seems to kind of fall down pretty easily. In my opinion, this is the only way I should have ever shown you how to do these. That's my opinion. Why is that? Because it follows along with your basic concept of just add the two equations together. I shouldn't have shown you graphing because, let's face it, I can't graph to save my life. And I'm the one trying to teach y'all how to graph. You're like, what's it, cover method? What? I still get people that put dots on, random places for the cover method. That obviously didn't work. Substitution, let's just have to manipulate too many things around. And then you wind up plugging it back into itself, and you're like, hey, everything fell out, infinite solutions. That's always unmotivating when I have a test and there's like 8 questions on it that are like this. And you get the kid who puts 6 of them are infinite solutions. Yeah, because I'd go with that one. Normally there's one infinite solution, there's one no solution, and all the rest solve. That's just a subtle hint to the person who wants to put no solution. That's like me telling you, okay, 4 of the questions on here are true, so you go through and put true on everything going, I got 4 of them right. Boy, the basic understanding is good here. I'm sorry, I'm making fun of people already. It's not even past our first period of this class for the semester. All right. First item, let's ask this question. Can I add these two equations together to get one of my values to fall out?
Not at all.
Nope. Do I have opposite x values or opposite y values? No. What might be something that we should choose to multiply by one of the equations, either top or bottom, that would then eliminate one of the letters? Well, let's pick a letter. Should I get rid of the x's?
Yes.
Should I get rid of the x's?
No.
If I were to get rid of the x's, I'd have to multiply one of the equations by a negative number, and I'd have to multiply probably the whole top by 5 and the whole bottom by 3, and I'd have to pick one of them to be negative. So I have to do 2 different iterations of this. Or I could probably get rid of the y's. How would I get rid of the y's on this problem?
Times 2 on the top.
Yeah, multiply the entire top equation by -2. So I'll distribute here, here, and here. Notice I went to all 3 terms. Let's bring this down. Right below this, I get negative times negative is positive, so I get 6x. -2 times y is -2y. -2 times 2 is -4. Okay? Could I add these 2 equations together as is right now?
Yes.
If I add these together as they're sitting, -5x added to 6x is 1x, which is x. The y's are gone. That was quick. That worked nice. I like that. All right, so I'm going to take that x value, 1 comma, we don't know. I have an x and a y value. What should I do with that x value?
Plug it in.
Plug it in. Okay? I'm going to plug that x value, this value here, here, or here, or here. I'd probably plug it into the top one. Plug it in right to that. Notice I didn't highlight everything. So I have -3 times 1 plus y is equal to 2. -3 plus y is equal to 2. So y is equal to?
5.
Done. Okay, so a few things that could take place with these problems. And they're all the same rules. Okay, I can get this. And this means I have one solution. I could work out a problem and I could wind up like this, where like 3x plus 2y is equal to 8, and -3x minus 2y is equal to 7, and I could wind up finding that 0 is equal to 15. What does that mean?
No solution.
This is no solution. And then I could also probably get some problem like this. If I add these together, I wind up with this, which means infinite solutions, because that's true. Okay, so if you have misplaced your workbook from last semester, you can come get one of these, but your assignment is going to be page 161, 162. And just a quick reminder, if you need one of these, please come get one. I'll put them up on this desk, and it should be good throughout the week, so don't misplace it. If you are pleased with how your grades were, keep doing what you did. Agreed? If you want to try and modify things, I'm available in my office before school, first period, third period, and fourth period. If you want to start saying, you know what, maybe I should, I'm not even going to take my math homework with me home, because when I'm sitting at home, it just looks like ants marching all over a paper. So maybe I should take advantage of coming in before school, first period, third period, or fourth period. Okay?